right, I've got a problem up here on the board, and I specifically wrote out the directions because I wanted you to see this is the way I'm likely to ask a question on quizzes and exams. So I say find and simplify the difference quotient for f of x equals 1 over x. So you'll notice I'm just using the word difference quotient. I'm not reminding you of what the formula is. That's going to be your job. Okay. But I am reminding you to record any restrictions on your variables that aren't otherwise clear from your answer. And in general, I'm anticipating that that's going to be that I've got to write that h is not equal to 0. Okay, so I like to just have a picture to help me remember my formula for the difference quotient. So here's f of x equals 1 over x. Now I happen to know what that function looks like. If you're asked to calculate a difference quotient for a function whose graph you're not familiar with, or for a function that you could figure out the graph, but it would take a while and that's not really part of the problem, it's totally fine to just say, I'm going to just use this, and by the way, this is not accurate. This is just a place for me to put my points. In this case, since f of x is one of our parent functions, that's not necessary. I can actually use an accurate graph. So I'm going to have a point, x, and then the y value is 1 over x. Now I've chosen to put it over here on the right side of the graph. Could just as easily have put it over here on the left side of the graph. Because remember, there's nothing inherent in the name x that tells me whether x is positive or negative. So this represents a generic or an arbitrary point on the graph of the reciprocal function. Then I'm going to have another point, x plus h. I usually, at least for this class, will draw it with h being positive, so that here's x plus h, and then h is just the distance between them. But it is important to remember that at least when we get to calculus, we're going to allow h to be a negative number. So if you drew your picture with x plus h to the left of x, totally fine. That just means you chose h to be negative. Okay. All right, the y value would be the reciprocal of x plus h. And then there's my secant line. So the difference quotient is just the slope of that secant line, which is rise over run. And it's always simplest if we start with the more complicated point. So the rise is going to be this y value, 1 over x plus h, minus this y value, 1 over x. And the run is just x plus h minus x, which simplifies to h. Okay, so there's my difference quotient. I want to simplify it. Okay. And I pretty much can see two things. First of all, this is a complex fraction. Anytime I have a complex fraction, I want to simplify it to get to just a simple fraction. But I also know when I'm working with a difference quotient that I'm anticipating that I'll be able to at some point cancel that h in the denominator. That's just your math teacher giving away that difference quotients can generally be simplified to that point. Okay, so how do I deal with a complex fraction? Well, there are a couple of options that I have here. One option would be that I could simply do the arithmetic on top. I could find a common denominator for those two fractions and write that as a single fraction, and then use the fact that division by h is the same as multiplying by the reciprocal of h. So I could write the top as a single fraction and then multiply by 1 over h. That's totally fine. And a lot of you might choose to do that because that sort of is what jumps out at you. I'm going to show you a technique that works nicely anytime you've got complex fractions for simplifying them. If I take a look, these are what I call my internal denominators. Those are the denominators of the fractions that exist inside of the top of this fraction. And there aren't any fractions on the bottom. So what I can do is I'm going to multiply by the least common denominator of those internal denominators on top and on bottom. Now if I do that, if I multiply by the same thing on top and on bottom, I'm really just multiplying by 1. That's a very useful technique for changing the way something looks without actually changing its value. Okay. Now it looks like x and x plus h have something in common, but they don't have any factors in common. So the least common multiple is going to just be the product of those two things, because I can't cancel across addition. So this x wouldn't cancel with an x here. I need a factor of x by itself to be able to cancel. And that's basically my goal. I want to cancel those internal denominators. So what I'm going to do then is on the top, I can just distribute this. And when I'm multiplying by a fraction, so my first fraction was 1 over x plus h, I'm just going to write this as a fraction, x times x plus h over 1. When I'm multiplying something by a fraction, and this isn't a fraction, just put it over 1. Okay. Minus 1 over x, again, times x plus h all over 1. And then on bottom, I've got h times x plus h. Okay. Now, on top, I can cancel that, and I can cancel that. And so what I'm left with then is x minus, be careful here, x plus h. I'm subtracting that whole thing, so make sure that that's in parentheses. And then that's over h times x plus h. Now, you'll notice when I canceled the x plus h here, it was in the denominator. It's not anymore, but it's still in the denominator of the entire fraction. So I can still see by just looking at what I have that x plus h can't be 0. Same thing here. I canceled an x, so it was in the denominator here. It's not anymore, but because there's still an x in the bottom of the entire fraction, I didn't lose the information that x cannot be 0. Okay, so now let's take a look at this. I'm going to just erase my picture so that I get some more room over here. What I need to do is distribute that negative. So that's going to become x minus h over h times x plus h. Those x's are going to cancel. So now I've got just negative h over h times x plus h. And now I can cancel those h's. So we get negative 1 over x times x plus h. This time when I canceled, now there's no longer an h on the bottom, and there's no h on any denominator, so I need to record that h cannot be 0. So in the original difference quotient, there were actually 3 things that couldn't be 0. X plus h couldn't be 0 because it was the denominator of this fraction. X couldn't be 0 because it was the denominator of this fraction. And h couldn't be 0 because it was the denominator of the whole thing. If I look at this, I can still see that x and x plus h can't be 0. But I have to explicitly record that h isn't 0. Now, if you want to also tell me that x isn't 0 and x plus h isn't 0, I'm fine with that because it's true. So if you want to record all of your restrictions, that's fine, but this is the one that it would be necessary for you to record. All right, I wanted to give you a chance to practice on difference quotients, but I'm also aware that the videos for this section have been going for a while, and you might be feeling a little bit antsy about getting to the homework. So what I'm going to do is this. Rather than giving you an additional problem from just the videos, I'm going to point out that question 35 asks you to find the difference quotient for x squared plus 4x. Can't remember, do they call it f of x? They do. They call it f of x. Okay. They ask you to find the difference quotient for this one. I'm going to suggest that you go ahead and try that problem. Check your answer. If you want, you can check it in the back of the book. Just make sure the back of the book won't record that h isn't 0. Make sure that you do that. If you got it right, no need to watch the next video unless you want to, but I will go over this one in the next video. But that way, as you do this problem, you're actually getting a head start on the homework as well. Okay? So I will possibly see you in the next video. If you feel confident about this and your answer matches what's given in the back of the book, and you wrote the restriction h isn't 0, and you choose to skip the next video, that's totally fine.